Okay, guys, so we're going to do a walkthrough for the one-dimensional kinematics 9 lesson, projectile motion. You should be able to qualitatively describe, so just tell me about the velocity and acceleration of projectile objects, and you should be able to read the graph of the motion. So hopefully you've already done your bell ringer. Today you are going to be filling out this document here. I would highly advise you to right click or two finger click on your touchpad, open with Cami so that you can type on it, and then you'll be submitting that as a PDF, right? So we will be working with this Phet simulation here. We will be in the intro part. We will move over to vectors in part of it. But let's look at the worksheet and what it's asking us to do. And we'll just kind of walk through that worksheet and get you ready for that. So here, I've already got the worksheet opened in Cami. And so let's see what we got. Today, we will look at the relationship that launch angle plays with projectile motion. In this experiment, we will change the angle of a cannon and see how it affects the distance a cannonball will travel. So we're going to open the link to the simulation. We don't have Edmodo, but it's already in your lesson. So ignore that part. We're going to click play button and then click on lab. Use the data table to determine what angle the cannon should be placed. After you fire the cannonball, use the blue data box, so that must look like that, to measure the distance the cannonball flew. Do this by lining the circle on the left of the blue box up with the spot the cannonball landed. So we'll look at that again, but it looks like we have little crosshairs here to really find how far that cannonball landed. And so we need this word here. Range is distance traveled. So that says in that blue box, it says range. So we'll be looking for that. Record the distance the cannonball travels on the data table, round to the nearest tenth. So we got some significant figures instructions there. And select a different projectile from the drop-down box on the right and repeat the above process. So I'm going to show you some examples with the cannonball. You are going to get to pick your own projectile and put those numbers here. Okay, and so let's go ahead and jump in and follow these instructions here. And so it said to go ahead to the lab part. Okay, and we want to have a cannonball is the thing that we're going to use first. And what does it tell us? It says firing angle of 25 degrees.
If there's anyone in the building that needs a hot dog or maybe kiddos want a hot dog so that we can clean that up in the red room, please help yourself at this time.
Sorry for that interruption. Let's go ahead and continue with our walkthrough. So we have firing angle, 25 degrees, 30, 45, 60. We have our cannonball selected. We want our angle to be 25. So there's 74. My cursor is making it difficult, but if you notice, there's an angle up here that we can see the measure as well. So 25 degrees. Okay, there's 25 degrees. I hope this dude moves out of the way. All right. And let's go ahead and fire. All right, so that is where we want to get our rangefinder, so to speak, right on there. And the range is 25.3 meters. So we are going to go ahead and type that in here, 25.3 meters. And it already says meters in our data table title, so we don't really need to type meters. We do not need to save that right now. And so 25.3 meters. And that's all you have to do. So then we're going to go back and we'll change this to 30 degrees. And we'll fire it again. This time we'll move our rangefinder. Okay, and it's a little hard to see, so let's see if we can go full screen. Yeah, still a little hard to see that one. So we could measure. Our measurement is 28.50. So 28.50. We're just going to hit enter after this one. And Cami, let us go ahead and select with our selector tool. We can select. Maybe we should have just restarted and select, and we'll make that font smaller so it'll fit better. There we go. And now we'll be able to just hit enter after the next one. All right. So you can go ahead and continue. What are the other numbers that you need? You will also need to change your object. So distance in meters for other projectile. Let's look at what your choices are. You can choose a tank, shell. You can use a golf ball, a baseball, a football, a pumpkin, a human, a piano, and a car. Okay, like we got to throw a piano. Let's throw a piano. So we're going to throw the piano and let's see what happens. Well, that's just interesting. A cannonball and a piano goes to the same spot. Kind of notice the way that path changes. Okay, let's look at our next question. So you go ahead and pause the video and finish these. You need to fill in these before you submit them. Okay? All right. Next instruction. What angle gave the most distance? Well, you're going to have to finish those before you answer, but you're going to say, obviously, which one is further, the cannonball or your other projectile of choice. Which angle gave the least distance? You're going to have to look at your angles and see which one had the smallest. It looks like 25 degrees is smaller between these two, but we could go ahead back and what would it be if we did a 90-degree throw for our piano? Let's throw a car. Let's see what the car looks like. That's zero distance. That was catastrophic. Let's go. So you're going to have to really investigate. You're going to have to look and see which of these angles has the shortest distance for the cannonball, which of these angles has the shortest distance for the projectile. So we're not really comparing the cannonball to the projectile. We're comparing the angles that they're thrown in for each of the objects. Write a complete sentence to explain how the launch angle impacts the projectile distance. You are going to have to talk about which angle and which one's for the least and the most, but how does that angle change the travel pattern? And we can kind of see that with what we have here. A lower angle, we had a pretty far distance, but then here at the 30 degree, it actually went farther, and then we started to come back in. So you want to kind of talk about height of our arch and distance, okay? And then it says, click the eraser button, set your launch angle to 75 degrees. Okay, we can do that. We can hit the eraser button and we can set our launch angle to 75 degrees. Right. And then the default velocity for your prior simulation was 18 meters per second. This time we're going to change velocity. So we changed angle in the last one. This time we're going to change velocity. So speed in a given direction as directed by the chart. So we're going to go start with 18 meters per second. I think I'm going to leave it on the car because that makes me happy. Our right here, I know it says speed, but it says velocity in the question. So 18 meters per second, and let's launch it. Okay. And then what do we write down? That was our other projectile this time. So what distance did it go? Let's get our rangefinder. 16.51 meters. If I change to 10 meters per second, so I'm actually going to go slower and launch it. Our angle didn't change, but the initial speed of launch did change. So what did we get? 5.1 meters. All right. What predictions can you make if we go 15, 20, and 25? What do you think? Okay, go ahead and finish these. So pause the video, Finish these on your own, and then explain the role that velocity has with projectile motion. So what you're talking about is the height of the arc and the distance that the object goes. Because we have the same distance. We have this car, or we have the same object. We have this car, the same thing, same mass, but obviously very different distances, very different heights of our arcs. And the only thing that we changed was the speed. So kind of discuss the way speed changes the travel pattern for your objects. And it says reset the velocity to 18 meters per second and change the cannon base height from 0 meters to 5 meters. All right, so we'll follow these instructions. This is what you're going to do. 18 meters per second, and we want to change the base height from 0 meters to 5 meters. Okay, and what else did it tell us to do? All right, let's see what happens. Just fire it. So we were at 75 degrees. We're at 18 meters per second. Our first launch was 18 meters per second. When we launched from a higher base, then our object went a little bit farther in distance. So explain that. All right, so the last part, you're going to write at least 3 sentences. So you're going to use some evidence, you're going to use some details, explaining in detail what factors affect the distance a projectile travels and how. So let's review. You changed velocity, you changed the height of the launch of the projectile, and you changed the angle of launch. You should use something about all 3 of those things in your description. Okay, so fill in every blank. And then what you're going to do is you're going to download with annotations and submit that PDF with annotations to today's lesson. Okay.